In this video, we will learn how to summarize data by creating frequency distribution tables for qualitative and quantitative data. Then we will see how to convert these tables into bar charts and how to construct histograms. This is basically descriptive statistics where we describe the distribution of our data. So let's start. What is a frequency distribution? Frequency distribution is listing down categories from our data, and against each category, we will write the number of elements or data points that belong to each category. So suppose 420 students get admission into a college, and you have data where column 1 contains student names and column 2 contains the branch or specialization of that student. Such data is raw data, but when you take out these branches as categories and find out the number of students that belong to each branch, you get a table like this. This is called a frequency distribution. Now these numbers on the right are the frequency of occurrence of each branch in our raw data. There is a term called relative frequency of a category which represents the contribution of that category to the total. That is, mathematically it is frequency of that category divided by the sum of all frequencies. So relative frequency for biotechnology will be 60 divided by 420, which comes out to be 0.14, which is nearly 14.2%. This same information can be depicted in the form of a graph called bar chart. In a vertical bar chart, the categories go on the horizontal axis and the frequency value is denoted by the heights of the vertical bars. This is a fairly common chart and is very easy to draw. Judging that which is the most popular branch may have been difficult if we were looking at raw data, but here we can easily see that most students go for electrical engineering and least go for mathematics. Earlier we saw frequency distribution for qualitative data. Now let's see frequency distribution for quantitative data. For quantitative data, we have to create the buckets first. And when we create these buckets and assign the frequency of occurrence of values that belong to that bucket, we get group data. So suppose we have a list of students and their science marks. This is ungrouped data. But when I create category of marks such as 0 to 35, 36 to 55 and so on, and find out the number of students who have scored marks in each category, I get this table, and this table is grouped data. Now we will learn to do this using softwares like Python. But for small number of observations, we can do it manually also. So let's learn how to do it manually. First, we have to decide the number of buckets. Usually, we keep it between 5 and 20. Next, we decide the class width. Class width is decided using this formula, which is maximum value minus minimum value divided by the number of classes that you have decided in the first point. Then starting with the minimum value, we keep on adding the class width to get the buckets. And once we have the buckets, we just need to assign the number of observations belonging to each bucket. So let's do it in an example for better clarity. Suppose we have the following numbers as customer ages. We want to group this data. First, we will select the number of groups we want to create. So let's say we want to create 5 buckets. Next, we find out class width using the formula. So 34 minus 7, the highest value, minus the lowest value, divided by the number of classes that we decided, which is 5, which comes out to 5.4, which we have rounded to 5. Now, starting with the lowest value, we add the class width to get 12. So first class is 7 to 12. Next is 13. We again add the class width and we get 18. So 13 to 18 is the next class. And we continue to do so till we get the last class, which is 31 to 36. The next column is called tally. We put a mark for each value that belongs to that category. So the first value 10 belongs to 7 to 12 category. So we put a mark here. The next value 14 belongs to 13 to 18 category. So we put a line here. And we continue to do so till we get to the last value, which is 33, which belongs to the 31 to 36 category. You can also notice that I have put a slanting fifth line. Having this slant line helps in counting. The last column is then the count of these lines. So first category has 2 lines, second has 4, and the last one with this slant line, which means 5 and 3 more, has 8 frequency. We have this table which has the frequency distribution. When we plot the frequency distribution of quantitative data, it is called histogram. I have created this in PowerPoint only. It is a little bit different than the table we created because the limits are in decimal points. So it is starting from 7 to 12.4 and from 12.4 to 17.8 because the actual value of the class width was 5.4. We rounded it to 5 for our convenience. So like bar charts, histogram is also representing the frequency values of each class. So whenever you get a data, it is good to plot a histogram so that you get the distribution of your data. So as you can see from this graph, most of the customers belong to the age category of 28 to 34 and very few customers belong to age less than 23. So we have very few teenagers, but we have a lot of young customers. Next, we look at some common shapes of histograms. There are three properties here. One is symmetricity, second is skewness, and third is uniformity. A symmetric variable distribution is same about the center. You can say that left is the mirror image of the right. So these two types are symmetric. If higher frequencies are more shifted towards one side and the other side has lower frequencies, then the graph is skewed as represented in these two graphs. If the frequencies are uniformly distributed in all the classes, then the graph is uniform. If we go back to the histogram we drew earlier, you can see that it is a skewed data. The frequency of the last class is higher and frequency of the previous classes is much lower. It does not have symmetricity since if you look at left part of this graph, it is not same as the right part of this graph, and it is not uniform since all the different classes have very different values. In the end, we will look at an important probability distribution called normal distribution. It occurs very often in the recorded data, and very often we make assumptions that the data is normally distributed. What this means is that our data is a continuous numerical data and the probability density at a point is actually a function of the distance of that point from the mean of that data. It is represented by this formula. We don't need to remember this formula. Just notice that the height y, which is the probability density at any point, is a function of the distance of that particular value from the mean. So x minus mu, distance from the mean, determines the probability density at any particular point. So when we have such data and we draw a histogram of such data, so if we create a number of classes and we assign the value, the frequency distribution of values in that classes, it will be drawn something like this. So the shape will resemble this. So in simple terms, what this graph is representing is the value at mean has maximum probability of occurrence, and as you go farther from the mean on either side, the probability of occurrence decreases. Also note that since y denotes probability density and not probability, therefore to get the probability of occurrence between a range, you will have to calculate the area under the graph. So for example, if you want to find out the probability of occurrence of value which is less than the mean, it will be area on the left of the side of the graph, and this will be half of the total area. We will not discuss here how to calculate this area and how to calculate this probability. The software packages which we are using in this course will automatically give us the probability for any range that we want to calculate. Listed here are three properties of normal distribution. The total area under the curve is 1 because this graph is showing the probability density. So if you want to find the probability of all values happening, it is 1. The curve is symmetric, and these two tails at both the ends, these extend indefinitely. We won't go deeper than this for normal distribution, as that is all we need for what we are going to learn later in the course. That's all for this video lecture. See you in the next video.